Hey there, curious minds. Ever wondered what would happen if every single person on Earth decided to jump at exactly the same time? It's a wild thought experiment that's captured imaginations for years, and today, we're going to break down the science behind this massive synchronized jump. Picture this. All 7.9 billion people on Earth standing shoulder to shoulder, preparing for the biggest coordinated jump in history. First things first, we'd need to gather everyone in one place. If we packed everyone together tightly, we'd need roughly 500 square kilometers, about the size of Chicago. Not too bad, right? Now, let's talk physics. The average person weighs about 62 kilograms and can jump about 0.3 meters high. When we all jump, we're essentially transferring our combined mass upward. That's about 490 billion kilograms of human mass leaving the ground simultaneously. But here's where it gets interesting. Would this mega jump cause earthquakes, shift the Earth's orbit, make the planet spin differently? The short answer is not really. The Earth's mass is about 6 septillion kilograms. That's a 6 followed by 24 zeros. Compared to that, our combined human mass is like a grain of sand on a beach. When we all land, we'd generate about 500 billion joules of energy. It sounds impressive, but it is actually equivalent to about 120 tons of TNT, or roughly the energy of a small nuclear bomb. While that's significant, it's still not enough to make any noticeable impact on our massive planet. However, the local effects could be interesting. The ground beneath our feet would experience some stress, especially if we're all gathered in one area. The impact force would be distributed across the surface we're standing on, potentially causing some minor tremors in the immediate vicinity. Think about it like this. If you drop a penny into the ocean, does it affect the tides? Not at all. The Earth is so incredibly massive that our synchronized jump would be like that penny in the ocean, barely noticeable on a planetary scale. But here's where the real challenges would lie. Getting everyone to the same location would be a logistical nightmare. We'd need massive coordination, transportation, and infrastructure to support billions of people in one area. The environmental impact of such a gathering would probably be far more significant than the jump itself, and timing. Getting everyone to jump at exactly the same moment would be practically impossible. Even with modern technology, the slight delays in communication and human reaction times would mean our synchronized jump would actually be spread out over several seconds. The most interesting effects would probably be social rather than physical. Imagine the incredible sight of billions of people coming together for one synchronized action. It would be the ultimate display of human coordination and unity, even if it did unshake the Earth. Speaking of social impact, this experiment raises fascinating questions about human cooperation. Could we ever organize something on such a massive scale? What would it take to get every person on Earth to agree to participate in the same activity at the same time? The air pressure changes would be notable too. When billions of people jump simultaneously, we'd create a significant displacement of air. It would be like a giant human-made wind gust. Though again, on a planetary scale, this would be minimal. Temperature would also be affected in our gathering area. The body heat of billions of people in close proximity would create a noticeable increase in local temperature. We'd essentially create a temporary human-made heat island. The sound of billions of feet landing simultaneously would be impressive too. It would create a thunderous boom that could be heard for miles around. Though the sound wouldn't travel globally, it would certainly be a memorable acoustic experience for anyone in the vicinity. From a scientific perspective, this thought experiment helps us understand just how massive our planet is compared to humanity. Despite our significant numbers and technological achievements, we're still tiny compared to the celestial body we call home. It's also a reminder of the incredible physics at work in our everyday lives. Every time we jump, we're actually pushing against the Earth's gravitational field, which is powerful enough to keep everything from mountains to oceans firmly in place. So while our synchronized jump wouldn't cause any planetary disasters, it would be an unprecedented demonstration of human coordination and a fascinating lesson in physics, logistics, and social organization. Don't forget to hit that like button and subscribe for more fascinating scientific explorations.